He doesn't shine. He doesn't emit X-rays. He makes no sound at all. But he's so absurdly massive that his mere existence has already changed everything we thought we knew about our own galaxy. This is Gaia BH3, a black hole that carries inside it the mass of 33 suns, compressed into a space smaller than the orbit of Earth. And here's the craziest part. He wasn't found because someone was looking for him. He showed up by accident, while scientists were doing completely routine data analysis. Pasquale Panuzzo and his team weren't hunting for black holes. They were just doing the daily grind, basically sorting through data, until a strange pattern appeared. An old star was dancing all by itself in space, being pulled by something no one could see. They stopped. They double-checked the numbers, and the result was so absurd they could barely believe it. A black hole with 33 solar masses, right here, in our own galaxy. Panuzzo later summed it up perfectly. It's a true unicorn. This is the kind of discovery you make once in a research lifetime. We tend to think of black holes as giant monsters lurking at the centers of galaxies. But there are smaller ones, called stellar black holes, born from the death of massive stars. They're the offspring of black holes, formed when the core of a dying star collapses. Most of them have between 5 and 15 solar masses. Very few reach 20. Gaia BH3 has 33. That's not just a bigger number. It's a number that makes scientists scratch their heads and say, wait, how is this even possible? But here's what makes Gaia BH3 truly special. Black holes this large aren't that rare in distant galaxies, but in our own Milky Way, current theory said it was almost impossible for one this big to form. Scientists believed that large stars lose a lot of mass over their lifetime and end up leaving smaller black holes behind. Gaia BH3 broke that rule. The leading explanation is that it was born from a very ancient star, made almost entirely of hydrogen and helium, with almost no heavy metals. These stars are more thrifty. They lose less mass during their lives. When they finally die, there's much more mass left in the core, which collapses into a much larger black hole. And one of the best pieces of evidence is that Gaia BH3 isn't drifting alone through space. Orbiting at a safe distance is a giant, ancient red star, a survivor from the early days of the Milky Way. This star is made almost entirely of hydrogen and helium, with very few heavy elements. It's what astronomers call a low metallicity star. And here's the most impressive part. It's exactly the same type of star that billions of years ago collapsed and gave birth to the black hole. It's as if nature left behind a perfect living witness to what happened. Gaia BH3 teaches us an uncomfortable lesson. The universe doesn't need to make noise to be powerful. Sometimes the most impressive things are the ones that don't scream, don't shine, and don't draw attention to themselves. They just exist and quietly change everything around them. The light we see from it today has traveled for over 2,000 years, but the black hole itself is far older. It's like we're looking at a living fossil that has survived since the earliest chapters of the Milky Way. A discovery like this doesn't exist in isolation. It forces astronomers to revise all our models of how massive stars evolve in the Milky Way. If a black hole with 33 solar masses could form here, how many others are we missing? It's very possible we've been drastically underestimating the number of black holes in our own galaxy. Now astronomers know they can find dormant black holes by measuring the subtle wobble of stars. This could reveal dozens or even hundreds of other silent giants hidden across the Milky Way. The event horizon of Gaia BH3, that point of no return where not even light can escape, spans roughly 390 billion kilometers. To put that in perspective, Neptune's orbit, the farthest planet in our solar system, would fit inside that boundary 40 times over. If you took our entire solar system, the sun, all 8 planets, every asteroid, comet, and speck of dust, and dropped it into that darkness, it would vanish completely. Without even brushing against the edges. It is a void so enormous that our brains simply struggle to register it. A place where space-time itself bends so severely that the normal rules of reality break down. Time slows, light disappears, matter as we understand it ceases to behave in any familiar way. And yet, all of this unfolds in total silence. No roar, no flash, no cosmic fireworks, just an immense, patient emptiness, existing for billions of years in perfect quiet. When you sit with that idea for a moment, it's hard not to feel the weight of it. Something this massive has been right here in our galaxy, only 2,000 light years away, and we had no idea it was there until very recently. In cosmic terms, that distance is practically next door. This discovery forces us to confront something uncomfortable. We thought we had a fairly good understanding of the Milky Way. We mapped billions of stars, tracked the central supermassive black hole, and believed we had a decent picture of how things worked in our galactic neighborhood. Then Gaia BH3 showed up and reminded us how much we still don't know. What makes this finding particularly striking is the company it keeps. Orbiting at a safe distance is an ancient red giant star, a survivor from the early days of the galaxy. This star is chemically primitive, formed when the Milky Way was still young and poor in heavy elements. Its presence acts like a living record, preserving the conditions that allowed a black hole this large to form in the first place. The implications stretch far beyond a single object. For years, astronomers assumed that stellar mass black holes in a mature galaxy like ours would rarely exceed 20 or 25 solar masses. Gaia BH3, with 33, suggests we may have been missing an entire population of larger ones. If one like this can exist here, how many others are quietly drifting through the Milky Way, undetected? This also changes how we search.
Instead of looking only for bright X-ray sources or dramatic jets, astronomers can now hunt for these dormant giants by carefully measuring the tiny wobbles of stars. The Gaia mission has already mapped billions of stars. Somewhere in that mountain of data may lie dozens or even hundreds of similar hidden giants waiting to be noticed. I make these videos because I'm genuinely fascinated by these stories too. If you enjoy understanding the universe in an honest way, without hype or exaggeration, just clear explanations that actually make sense, then I'd really appreciate it if you subscribe to the channel. Just hit the subscribe button and turn on the notification bell so you don't miss the next ones. I've got a lot more interesting stuff coming. Thank you so much for watching until the end.